Good morning, my name is Nicolas Montalban, and today I'm going to talk about CohLitheSP, a new technique to study quality in specialized translation. First, we are starting with the introduction. Some studies mention that machine translation is almost like human, or that it gets closer to that of the average human translator. Arenberg states that the aim of machine translation is overcoming language barriers, although human translation is aimed at producing texts that satisfy the linguistic norms of a target culture and are adapted to the assumed knowledge of its readers. It is also impossible to overcome the perfection of human translation, as Jan van Regie and Lapalme states. House defines translation as the result of a linguistic textual operation in which a text in one language is recontextualized in another language. And also, Ikari states that equivalence is one of the most important aspects of or goals of translation. A translator has to focus on researching for the best equivalent terms between two different languages or dialects. As far as the methodology is concerned, we had to say that we have been using a collection of texts in English dealing with quantum physics, technology, medicine, environment, and geology, an extract from Red Dirt, a selection of 5 scientific technical texts in Spanish, and an extract finally from the book Escritos de un viejo indecente by Bukowski. The first evaluation metrics we are introducing here are precision and recall. First, we must count the number of words in both the machine and reference translation. In order to do a calculation with precision, the number of common words is divided by the number of words in the machine translation. The calculation of recall is achieved by dividing the number of shared words by the number of words in the reference translation. We consider a system to be good if scores are high, so the best system is the one with the highest scores. Where error rate is another metric we are implementing. In this method, differences such as substitutions, insertions, and deletions are taken into account. This metric is based upon the Levenstein distance, calculating the word level. In this case, the lower the word result, the better. But the most common metric used is bilingual evaluation under study. This method discovers how many engrams are overlapping between the machine translation and reference translation. This metric is based on the idea that the larger the number the engrams overlapping between the machine translation and the reference translation, the better the machine translation is. Also, we are using MakeCut. This is a free and open source online cut tool. Assignments are organized into projects in which the user specifies the source language and the target language. WordFast Anywhere is another cut tool that we are using. The text is divided here into segments that are being translated and stored, creating glossaries and translations, which will appear in future translation depending on the index of coincidence of words. As far as my methodology is concerned, or to analyze the appropriateness of the texts as regards reading, a code in Python language has been developed. To apply the aforementioned metrics, the following are needed: a reference text conforming to a valid corpus, a glossary of technical or specific terms, which is helping to know which words are specific within a corpus. These terms will not include measurement units nor words of stop. A set of connectors allowing to know when in a sentence something is being inferred from something previously said. The Syllactic metrics under changes are narrativity. It is calculated determining which words of the text to be evaluated are already being recognized in the reference text. Readability determines the simplicity of the text in this language. In the case of Spanish, the readability of Fernandez has been chosen. If someone wants to do it for the English language, it only needs to be changed with the Flesch-Kincaid, whose formula is also based on a similar calculation. Then we also have the referential cohesion. In this version, the same referential cohesion as in cometrics is calculated. The deep cohesion, it determines the incidence of the connector over the recognized sentence. And concreteness, in this version, instead of corpus of the language, the incidence of the terms of the glossary is determined from the recognized words in the reference text within the text to be evaluated. After applying the simplified version of cometrics over the produced texts in Spanish, it is possible to see how, after being evaluated separately with a mark from 0 to 10, they seem to describe a similar curve, as it can be seen here. As we can observe, with the exception of narrativity, the maximum mark is not achieved in each parameter. So first the weights for each case are applied, and later a rule of 3 with the maximum mark 10. The result will be the constant by which all texts using this reference amplification context over the texts of the technological corpus as reference is needed. This formula is being used after calculating the coefficients from the program. Under these weights, marks of the 6 reference texts have been studied, and it has been found an amplification of 1.39. Regarding the calculation of the marks of the texts, the amplification constant must be applied by the addition of each metric divided by its maximum and multiplied by its weight. For example, the following formula can be observed over the technological texts. Okay, the formula is this one. As far as the conclusion, it is important to say that in this work, a new and different tool has been shown which adds a supplementary challenge for students, the possibility of improving the readability of their own translations from English into Spanish, given the facts the technique explained before is working properly mainly due to results. On the one hand, it is proof that different texts coming from different typologies, including machine translation texts, get good or bad marks in the same metrics. On the other hand, the texts also show that after refining the final mark with the amplification mark, the result is approximate to a student's evaluation. Moreover, it is important to stress the easy programming of this CohLitheSP, which does not require large corpuses, despite the fact that it comes from systems needing an enormous extra charge in the development of programming. This last feature is complemented by the fact that it is easily transformed to be working in any language. The procedure used to test the new tool implemented with the external evaluations should also be highlighted. Thank you very much for attending. my presentation.